Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello, this is Ian Woolf. Due to technical problems, this week's show on Savannahsaurus won't be broadcast until next week. Instead, please enjoy this show that was first broadcast on the 7th of September 2011.
Hello and welcome to Diffusion. Feel amazing and bizarre science wriggle into your brain. I'm Dr Julianne Popple. On this edition, we'll feature medicinal maggots and seagrass meadows. But first up, here's the news with Victoria Bond and Ian Woolf.
Astronauts may need to take the unprecedented step of temporarily abandoning the International Space Station if last week's Russian launch accident prevents new crews from flying there. Until the officials can figure out what went wrong with Russia's essential Soyuz rockets, there will be no way to launch any more astronauts before the current residents have to leave in mid-November. The unsettling predicament came just weeks after NASA's final space shuttle flight. Flight controllers could keep a deserted space station operating indefinitely as long as all major systems are working properly. The risk to the station goes up, however, if no one is on board to fix the equipment breakdowns. Currently, 6 astronauts from 3 countries are presently living on the orbiting complex. 3 are due to leave next month, and the other 3 are supposed to check out in mid-November. They can't stay any longer because of spacecraft and landing restrictions. So can you explain to me, Ian, what it means to be in a post-shuttle era? Why isn't NASA shuttling any more astronauts to the space station?
Well, this goes back to a plan they've had last 5 years from the Bush era, when they planned to wind down the space shuttle, because after all, it's a 1980s era craft that's still travelling in, 30 years later. So it's time to put up something new. But they don't have a budget for something new. And they didn't have a budget for it 5 years ago. So what they're hoping is with all these companies that want to go into space, like Virgin Galactic and all the other companies that have been in the X Prize to try and put a man into space, they were kind of hoping that by now they'd have a thriving commercial space industry that they absolutely don't have. So now that the shuttle's retired, there's only Russia. And when Russia can't do it, no one can do it.
We'll have to get back and see what happens after mid-November, see if any more astronauts make it, and if it flies unmanned. Hopefully not, considering it took decades to get the station up in the first place.
The other bit of news is that the Ultimo Science Festival actually got extended, and they had an Art Meets Science event. Art Meets Science, they invited a whole bunch of scientists and artists. At the door, everyone got a name tag. You either got a red dot or a green dot. Red for science, green for art. Some people got both, depending on what they did. They had a microscope set up, and when you look down the microscope, what you see is not just the slide, but it's a little tiny video screen that is magnified because of the microscope. And so if you're looking at, for example, Curiosity, labelled on the slide, you put it underneath, and there's an eye looking back at you moving around. Take that slide off and put on Out-of-Body Experience, put the slide in there, look down, and you can see yourself from the side looking down into the microscope. There's another one labelled Beginnings, which has an exploration into space. And a rather bizarre one, the artist was telling us that she was doing some experiments with microscopic pond animals that she'd obtained on the internet. And when it came time to be finished with them, she contacted them to say, how should I get rid of these properly? And they said, well, either you can release them into a pond, or you can flush them down the toilet, or you can feed organism A into organism B. And she thought, I'll take the third option and film it. And so she did. And it turns out to be much more horrific and gruesome than you would ever expect. It's like something out of Alien. There's all this tentacles and bursting, and it's really, really horrible. And that was the 5th slide that you got to put that underneath and wow, into your face. Stellark, the famous Australian artist, was there, and they have an installation at the Powerhouse Museum that you can go and see of his articulated head. An articulated robot arm, like an industrial robot, that has a monitor on the end with a computer version of Stellark's face. Now this face looks at you, and it doesn't just look at you. If you move around the glass enclosure where the arm is to keep you safe from an industrial robot arm, the face will follow you around. It will blink, it will look at you, and if you speak, it will speak back. And in fact, if there's two of you, we thought, we'll see what happens if one of us goes left, the other one goes right. And it sort of gave us a quizzical look, raise one eyebrow, and then follow the other one. So there's a lot of clever programming involved, and they're collecting more data because they're watching the people that interact with the robot to get their reactions and program more responses in. There were 2 extra robots there that were mobile on wheels, and they also had monitors with Stellark's face, and they also responded. And a Canadian artist, Erin G, was there working with the robotics team, and she performed with all the Stellark faces. She actually sang and danced with her own monitor, which was sometimes her face and sometimes Stellark's face, and that video will be up online. While she was doing that, the real-life Stellark was videoing the whole thing. They also had a woman there who's a photographer using a very old large format camera. So it's a film camera, and it's sort of like an A4 sized piece of film. So to make prints, it's just straight contact. But because it's such high resolution when you're using film, when you're using oxidizing silver, you're talking about sort of nano level density, which means you can actually blow these up to billboard level and they'll still be high resolution. And she's photographing all the odd and interesting gadgets in the Powerhouse Museum, and they're beautiful photographs. And the last thing they did was they had a speed meeting. They had all the people with red dots, the scientists, sitting on one side of a long table, and the people with green dots on the other side, the artists. If you had both dots, then you got to choose which you wanted to be, and you had a short conversation with each person and then moved on to the next and the next and the next.
So how'd you go, Ian? Did sparks fly?
It was a very interesting night.
Next up, Victoria Bond spoke to Professor Pinas about creepy crawly maggots and dermatology.
Well, my name is Pablo Fernandez Peñas. I'm an associate professor at Sydney Uni and in dermatology and head of the Department of Dermatology at Westmead Hospital.
Can you tell me a little bit more about the use of maggots in dermatology?
We have the unusual experience in dermatology that some patients that they develop skin cancers and tumors, if they're neglected, sometimes fly, they put their eggs and then they're maggots. And we've seen, this is all experience, that the maggots will destroy all the tumoral tissue, will kill all this, destroy, clean the ulcers quite well, clean the area quite well, and never get into the living tissue. So that was a good finding, and what some groups decided to explore is because cleaning an ulcer from all the necrotic tissue is quite important, and we usually have been using what is surgical debridement, so we take a blade, clean the ulcer, and try that the ulcer is healing. On the other hand, maggots, they're quite good. They only go to the necrotic tissue, they're not ever going to touch the living tissue, and could do the job for us. So there's a few groups that have been exploring this technique, and now it's available here, and we have used that in our patients.
So the maggots would actually be beneficial to the healing process of these ulcers?
Mainly, we know that in ulcers, in cutaneous ulcers, the presence of necrotic tissue or high amounts of fibrin is going to slow down the healing process. So we need to take it out. We could do chemical debridement, we could do surgical debridement, or we could use maggots that are going to do the job for us. And one big advantage to compare to the surgical, that is painless.
And is that because they're very precise or slow about it? Why?
Yeah, mainly because they're very precise. They only eat what they need to eat and they don't touch anything else. It's quite interesting.
And do you think you could just explain a little bit why the fibrin is there in these ulcers?
Yeah, when you've got an ulcer, all the fluid and the proteins that we've got in our body, mainly our body is 70% water, so the water is going to drain. The fibrin that is in the blood is just to contain that the blood and the water is not getting out if we've got a wound. That's the role for the epidermis, but if we've got a wound, it's that the epidermis is gone. So this is the second line of defense. So the fibrin is trying to contain all the fluids inside the body and trying to create a membrane that is not as good as the epidermis to avoid products or bacteria, microorganisms, substances going into the body. So it's a type of temporary protection for the body while the healing process takes place. So we've got this fibrin that could be good if you're in the outback, but we know that in the long term it slows down the healing process.
Okay. And is this something we could expect to see in the future much more? I mean, going to the GP and prescribing maggots?
I think that's going to be quite difficult because the technique to use is a little bit complex yet. And because of probably the fear for many patients to see crawling larvae on your skin. So I don't think it's going to be that popular, but some patients, they really appreciate that it's a useful tool in the right hands.
And most of all, painless.
Yeah, painless. That is compared to the surgical things. It's true that there's a good dressings, and some dressings they could do a part of the job, but when the dressing is not doing, maggots is for sure a good answer for this question.
Professor, thank you very much.
You're welcome.
So Julianne, as our resident entomologist, I thought you might have appreciated that.
Oh, I thought it was great. I love maggots, and you know, the term is biotherapy when they use it to clean wounds and things.
So yeah, I was wondering that, what makes a maggot medical grade?
Well, it has to be a species that feeds purely on dead flesh. There are other species that will feed preferentially on living flesh, and obviously you don't want those in your body. So I can't remember which particular species they use in medicine, but I know it's one that definitely only feeds on dead flesh, and they culture it within the hospital, so under very sterile conditions.
See, I was feeling kind of warm and fuzzy towards maggots and their helpful attitude, but now that I know that there's flesh-eating maggots, I'm much less into the idea of putting them on my skin.
Well, these ones are great because, I mean, from what I understand, you don't actually feel them when they're actually feeding on the flesh. You don't really feel them. What patients have commented on in the past is that you can feel them if they crawl out of the wound across your skin, then you feel it, and that can be unpleasant just because it, tickles. But they actually put some gauze around the wound to stop that from happening, so the maggot crawls out, they'll remove it. But in terms of ones that feed on living flesh, that's mostly a problem for sheep and livestock. Very rarely, unfortunately, you'll see cases in nursing homes where elderly people will have infections or infestations of maggots, but that's very rare, fortunately.
And from what I understand, I mean, this is hardly a new technology. People have been putting maggots on wounds for millennia.
Yeah, and actually there's a great story. Have you heard the story about the Stinson plane crash in southeast Queensland? There was I can't remember exactly when it happened, I think it was in the 40s or the 50s. A light plane crashed in the Lamington National Park area. One of the guys had a nasty wound to his leg. He managed to crawl out of the plane, get into the forest. His friend went looking for water, but he had this nasty wound, and the only reason he actually survived and didn't die from gangrene in his wound was because maggots came and ate the dead and rotting tissue, and his friend came back with water and they both survived. And for him, because of maggots.
And it was the same time period as well, World War II, that they would bring maggots to the soldiers to prevent gangrene. It was exactly the same reason.
One way to really sell maggots to people in terms of a biotherapy is to look at the alternative, which is a very harsh metal scrubbing brush, which I heard is very painful. So, painless but psychologically a little bit creepy crawly. I'd take that any day over a painful scrubbing brush. And that was Victoria Bond speaking to Professor Pinas of the Dermatology Department at Sydney University. You're listening to Diffusion Science Radio. We're brought to you across Australia on the Community Radio Network and over the internet on www.diffusionradio.com. Meadows under the sea feed the world and clean the air. Dr Peter Macreadie is a marine ecologist in the School of the Environment in the Faculty of Science at the University of Technology, Sydney. Dr Macreadie has been nominated for the 2011 Eureka Prize awarded each year by the Australian Museum for his research into the role of seagrass. Ian Woolf began by asking him, what are seagrasses?
Seagrasses are a flowering plant. If I were to describe seagrass and what most people have encountered, it would be something much like the grass you'd see on a football field, but it's underwater and it grows in the shallow coastal margins along our Australian coast. So that interface between land and sea, and it occurs right around the Australian coast. In fact, it occurs on every continent around the world except Antarctica.
What role does the seagrass have in the marine ecology?
Well, we've typically known as these systems, or the most well regarded for their provision of nursery grounds for juvenile fish. So they give these fish food, shelter, protection from predators. Now we estimate that they support around 50% of the world's fisheries. And now many of these fisheries are in developing nations, so we're talking about valuable nutrition for about 3.5 billion people. but they also have a number of other roles. They stabilise our shoreline and prevent coastal erosion. They play an important role in cycling nutrients. It's been estimated that they're worth around $1.8 trillion a year globally in terms of their nutrient cycling value. And they give a lot of important habitat to iconic species, dugongs, turtles, swans and so forth. And what we've recently learnt is something that is totally profound and perhaps the most important ecosystem service of all, and that is that they are one of the most powerful carbon sinks on the planet. So they have an amazing ability to capture and store carbon.
And just how much more carbon do they store than, say, rainforests?
They don't have as much area as rainforests, but they are 30 times more powerful at capturing and storing carbon. That's what's really unique about them. The other thing that separates seagrasses from terrestrial forests is that they store carbon for really long periods of time. Okay, so terrestrial forests typically store carbon for decades, maybe a century at most. But we've recently found that the seagrasses store carbon for thousands of years.
So when you say they store them for thousands of years, does that mean that when they die, they stay on the bottom of the ocean and they don't rot very fast?
Yeah, well, I guess in terrestrial forests, there's much more turnover of the carbon, and the carbon is held within the actual wood itself. Whereas with the seagrasses, a lot of the material gets put in roots and rhizomes and the plant material itself and little particulate matter that gets stored in the sediments. And a lot of that isn't very digestible for the microbes that might otherwise push it back out into the atmosphere. And so it gets buried away and it gets deeper and deeper with accretion of sediments. And actually in Botany Bay, the site of European settlement here, we've taken cores around 4 metres deep. And at that depth, we're talking about sediments that are about 6,000 years old. And we're still finding seagrasses with carbon signatures from seagrasses. So we know that they're storing for thousands and thousands of years. That's what we found here in Australia, and it's also been shown throughout Europe as well. This is the case.
With seagrasses being so important to the marine environment and being worth over $1 trillion just to the fisheries industry, and now possibly being really important to the carbon cycle and global warming, how safe are they?
The seagrasses are referred to as the coal mine canaries of coastal ecosystems. When something bad is happening in the marine environment, they're extremely sensitive and they're usually the first to disappear. We've lost probably at least 30%, some people believe 50% of the world's seagrasses. And because they sit at that interface between land and sea where a lot of the human activities take place, they really cop a pounding. And we often only learn of the importance of seagrasses when it's been lost. I mean, we've seen it happen around the world where a local fishery will collapse and then they draw that link between the loss of the local seagrass meadow perhaps a couple of years earlier. So they are desperately needing protection, and it's a dollars game, really. I mean, when we're dealing with the government and we're dealing with industry, it's a case of we're constantly urbanising our coast. We're constantly putting in new infrastructure. I mean, you look around Sydney and there's very little areas of water that have the natural environment, the environment they've always had. There's a lot of rock walls, there's a lot of barriers, there's a lot of strange sort of artificial structures, and seagrasses now struggle to grow in those environments. And not just that, with nutrients going into the surface waters can create algal blooms. We see more and more ports being put in that involves dredging, and so the seagrasses often die off from lack of light. And so one of my goals really is to translate how important seagrasses are in dollar terms. And that's an important thing in terms of getting resource managers to invest in their protection. And so in the case of, for example, carbon capture and storage, my colleagues and I estimate that their Australian seagrasses are worth around $45 billion a year in terms of carbon capture and storage. And that's based on Julia Gillard's, the Labor government's $23 a tonne price.
Are the policymakers likely to try and increase the amount of seagrasses? Is that a useful thing to do, or is that going to mess things up further?
First and foremost, it's about protecting what we've got. And then I think secondly, we can look at replanting seagrass from where it's been lost. And what I'd like to see is industry investing in rehabilitation of seagrass meadows. I mean, it's quite expensive to do, but if these companies want to offset their emissions, then perhaps they can invest. Much the same as we've just had this carbon farming initiative introduced, got passed through the Senate last week actually. And so this is about replanting trees in Australian landscapes, often which have been converted to farmlands for agriculture. And so replanting seagrass from where it's been lost and looking after what we've got. And I think what's also really important to understand is that seagrass sit often on a tipping point between being a source of carbon, that is, they emit more carbon than they take in, and being a sink of carbon, so they take more carbon in than they let out. So it's this, I guess it comes back to photosynthesis and respiration. It's this balance between having those two in the right amount to make sure that there's a lot of carbon capture and storage.
And you've been nominated for the 2011 Eureka Award prizes.
The university nominated me for the Young Early Career Researcher Award. And then I got this call from the Australian Museum saying, congratulations, we've selected you for the People's Choice Award. I didn't really realise what I was getting myself into initially, but the promotion has just been fantastic. So this is my opportunity. I've learnt to promote the importance of seagrasses, the need for their conservation. We're here to use seagrasses to help reset our planet's thermostat. So, we're hearing a lot these days about reducing carbon emissions, but it's about those emissions that are floating around our atmosphere now and will continue to do so for another 100 years. What are we going to do with those emissions? And so this is about using, a lot of people refer to it as biosequestration. It's removing atmospheric carbon and locking it away over long periods of time.
Can you tell me something about Seagrass Ink?
Yeah, Seagrass Ink established at UTS back in 2010. This was something that Peter Ralph and I and a couple of other people from the commercial group at UTS put together. And we sort of looked around and thought, this is a one-stop shop for great seagrass research. We've got some amazing expertise. We've got some of the gods of the seagrass world here at UTS. So let's put together Seagrass Ink. And I'm hoping that in the future it'll be a group that industry will go to when they're looking to perhaps invest in seagrass offsetting programs. It'll be a group that government will turn to perhaps when they need strategic advice or they need monitoring. So it's a brand name that we can use to put together all the seagrass expertise we have at UTS. So during my PhD, I was wanting to look at the effects of seagrass habitat fragmentation on fish populations. Now, I wanted to do this as realistically as possible. So I wanted to fragment seagrass on realistic scales. Now, I didn't want to touch the natural seagrass in Port Phillip Bay. It had already copped quite a pounding. I mean, over the years, it had been bulldozed from right up and down the east coast in my childhood years because people didn't like the feel of it underneath their feet. And so I used artificial seagrass and I based some experiments on natural fragmentation in the real environment. Now, artificial seagrass is basically green Christmas ribbon tied to steel mesh. Now, to do this on realistic scales, the seagrass had to have a density of 3,520 leaves per metre squared. So really dense stuff. That green ribbon has to be hand-tied to steel mesh. And all in all, I needed to hand tie over 250 kilometres of green ribbon to steel mesh. That's a distance from Sydney to Canberra. And so we had this really great community project. We got in touch with a group called Ability Works Australia, employs people with mental and physical handicaps. And we had a team of about 15 people working solidly over 2 to 3 months, hand tying all that green ribbon to steel mesh. And that artificial seagrass has been used in half a dozen or so major experiments and has been published in the peer-reviewed literature and worldwide. I get emails all the time from people around the world just saying, how did you get artificial seagrass made on such large scales? And that was thanks to Ability Works Australia and that community project getting it all made.
So tell me about Science Meets Parliament.
I went to Science Meets Parliament earlier this year, and on the first day we received training, which is how to interact with the politicians. And then on the second day we were assigned with politicians. And the take-home message I got on that first day of training is that you've got 8 seconds to grab the attention of a politician, otherwise you've lost them. And so in my case, I was meeting Minister Martin Ferguson, who is a Cabinet Minister for Tourism, Trade and the Environment. I approached him first off and said, I can help you save $9 billion. Now, the reason why is that around the world we're approaching a global peak in the number of offshore petroleum structures that are due for decommissioning. These things are absolutely huge. They have footprints the size of football fields. They stand as high as the Eiffel Tower. They weigh more than 10,000 family cars. They're absolutely gigantic. And in the next 5 to 10 years, about 85% of the world's offshore petroleum rigs are about to reach the end of their production life. And while they've been sucking oil out of the ground, they've become home to really important fish species, and they've been protected from illegal trawl fisheries, especially in the deeper waters. They've become home to a lot of slow-growing corals. And in the Gulf of California, they found that if you rip out one of these rigs, it was equivalent to removing about 70 acres of natural habitat. And so for 10 years there was this bill that they were trying to push through Parliament, industry was trying to push through to convert rigs in artificial reefs. Now they can save a lot of money by doing so. A typical rig might cost $200 million to decommission. You save about half that if you convert it into an artificial reef. And so industry had been pushing this for so long, and eventually it was actually some research scientists that produced a number of papers which actually said this could be beneficial for the environment. So despite this public view of we're dumping rubbish in the deep sea, they found that it was actually really good for the Californian conservation efforts. And so here we have in Australia about 65% of our offshore petroleum structures, our offshore rigs, about half of those are due for decommissioning in the next 5 to 10 years. And so grabbing Minister Ferguson's attention was by letting him know the potential cost savings here and the need for research into converting these into artificial reefs. So we need to understand the risks as well as the benefits. We know the benefits, they're quite clear. Amazing money savings and potential value to conservation and rehabilitation. But there's a lot of risks here too. We could spread invasive species. These rigs could disintegrate materials that could end up through the food chain and so forth.
Good luck with the Eureka prizes.
Thank you.
Peter Macreadie, thank you very much.
Thank you, Ian.
That was marine ecologist Dr Peter Macreadie, Chancellor's Postdoctoral Research Fellow in the School of the Environment at the University of Technology, Sydney, and nominee for the 2011 Eureka Prizes for his work on seagrasses. And that's all from us this time on Diffusion.
Send email to science@diffusionradio.com. That's science@diffusionradio.com.
And tell us your thoughts, feelings and stories. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com. Contributing to the program were Victoria Bond and Ian Woolf. Diffusion has been produced by Ian Woolf in Sydney. Diffusion is broadcast nationally via the Community Radio Network. I'm Dr Julianne Popple. Join us inside your audio device of choice for more science wandering next week on Diffusion Science Radio.